Okay, hi everyone, welcome back to this video series for Introduction to Firewalls, Detecting an Intrusion in Progress. Intrusion detection systems exist in many different forms. We're only looking at the intrusion detection system that can occur at the firewall by analyzing the stream of packets arriving at the firewall. Other systems may detect other systems may detect things such as unusual RAM or CPU uses, unexpected changes in file dates and sizes, or statistically noticeable anomalies in a user's usage patterns. The major difference between packet filtering and intrusion detection at the firewall is that packet filtering decides which network traffic is allowed to enter the internal network, whereas inspection-based intrusion detection doesn't control the network traffic but attempts to recognize patterns or conditions in one or several packets blocked or allowed in order to spot an intrusion in progress. Intrusion detection systems actually work a lot like virus scanning software. They use a list of signatures that specify what constitutes a possible usage pattern an intruder may attempt. Sometimes this list of signatures is updatable with a newly discovered attacks. The following list describes common events or patterns that an intrusion detection system may detect. DNS zone transfer. There are several documented ways that a hacker may exploit the DNS service running on the firewall. Obtaining DNS naming information by doing a reverse query on all IP addresses in a given range or by initiating a DNS zone transfer are two examples that may be detected by the intrusion detection system. Address scans. An attacker may scan a range of IP addresses to see which one is responsive to its queries. The intrusion detection system should recognize the repetitive nature of the IP address scans, port scans. Perhaps the most common tactic a hacker may use is the enumeration of open TCP IP ports on the firewall's external network interface. The hacker attempts to connect to ranges of ports to find out which numbered ports appear open and subsequently can be used to mount another attack. The intrusion detection system should recognize the sequential scanning of ports. Some hackers use a random port number in an effort to outsmart the intrusion detection system. Ping of death, tier, land drop, win nuke. These are all names of various types of malformed IP packets that can cause older TCP IP implementations to misbehave or even crash, especially the ping of death attack, where an ICMP ping packet with an unusually large data portion is sent was notorious. Reacting to a security incident. Your response to a security incident depends on the nature of the attempted attack. Some attempted attacks require no action at all, whereas other continued attacks may require that you contact law enforcement authorities. The internet is very large and houses many would-be attackers. With the help of automated tools and scripts, it's easy for a bored hacker to routinely scan large blocks of IP addresses for interesting ports. This means that on any given day, your firewall may report hundreds of port scans from different IP addresses from around the world. This knob rattling is nothing to be alarmed about. Other attacks may be more worrisome. If a continuous stream of malformed IP packets targeted at your site interrupts normal operations of the firewall, or if possible intruders appear to have already entered your network, you may have to take some action. Hopefully your intrusion detection system or the generated reports of the firewall logs alert you to do some alert you that something is up, depending on the severity of the situation. Here is what you should do in these cases in order. Do not panic. Document. Not panicking is the kind of advice you can randomly insert in any list of what to do tips on any topic. But when you detect an intrusion on your network, it's particularly important that you react hastily. If you notice that the attacker is still assessing your network while you watch, you may feel the need to immediately do something. If you panic and therefore take the wrong action, such as adding a firewall that mistakenly allows more network traffic or deleting a log file instead of copying it, the attacker may actually benefit from your reaction. Resolving an intrusion attempt may take a while. To be honest, you may have to add order pizza to the preceding list. Document everything you do is important to be able to restore a previous situation later, and to make it easy to involve other people during the incident in progress. You may even need the chronological documentation as proof if law enforcement authorities get involved. During a serious attack, you won't have much time to think about whom to contact: management staff, security staff, personnel, users, pizza place, the firewall vendor, internet service provider, other sites, and so on. In which order and what damage control actions should be taken. You should create a notification plan beforehand. The plan should include all relevant phone numbers and inventory of needed materials such as spare hard disks, and policies on crucial steps such as which machines to disconnect and when to notify which people. You may even agree on a scheme about how to communicate with others in the organization without divulging to the intruder that you are aware of the attack and that a response is underway. You may look like this. Attention all users, the surprise birthday party for Alice is commencing in room 4 at 7 p.m. Bring your own discs, Bob. Immediately disconnecting everything may be the easiest approach, but taking snapshots of the current situation and trying to understand how the attack could have been possible is another useful tactic. Of course, if the intruder is actively destroying things, people may not appreciate your allowing it to continue while you find out what's going on. Your plan should also include how to restore normal operation after the incident has ended. The plan might reinstalling the firewall and related software from scratch to avoid the danger of leaving a Trojan horse style program or another backdoor created by the intruder. Many fascinating books such as The Cuckoo's Egg by Clifford Stroll recounts classic stories of how a brave firewall administrator, usually the author of these books, followed every step of the attacker, hunted down the intruder, and in the following months eventually got the bad guy arrested, which finally restored peace in town. Don't expect to gain a book deal out of your brush with a hacker, but such accounts are certainly an entertaining and interesting source to find out about tactics hackers use. Improving performance by caching and load balancing. You want to make the firewall a single point of control for all network traffic going to and from the internet, which means that all traffic is funneled through this one entity, possibly affecting response times. To make matters worse, the firewall is actively inspecting all packets flowing through it, and at the same time has to update log files describing the network traffic. The operating speed and the capacity of a firewall are important aspects to consider. In general, two approaches can be taken to improve the performance of a firewall. Serve results from cache. Previously obtained results are cached locally in order to fulfill equivalent requests more quickly. Later, balance the load. The same service is provided by several machines that either work together to divide the total load or work independently. Caching web results. A web proxy service that is handling the web requests from client computers can restore the returned results, that is the web page elements such as graphics and text, locally on the disk. Subsequent queries of the same content can then be returned using the locally stored copy instead of going out to the internet website again, which is two advantages. Improved performance. The firewall can return results to the requesting clients quicker. Lower connection costs. The connection to the internet is used less often, which could mean cost savings on connections that have costs associated per used megabyte. You may even decide that a smaller bandwidth connection is sufficient. Of course, the advantage from caching the results will be obtained only if users frequently access the same website. An HTTP page can specify an expiration date in its code. The header of an HTTP page can also contain special information called meta tags that specify whether a specific page should or shouldn't be cached. The web proxy service should obey those indications, which is essentially important on web pages that change frequently. Certain web pages will not normally be cached, including those that are encrypted by secure socket layer SSL and also HTTPS or that contain user authentication data. Many firewalls expand on the basic caching mechanism to try and improve the number of times a web request can actually be served from the cache instead of having to go out to the internet to get the content, of making the user wait longer for a response. Some techniques that are used to improve caching hits are active caching. The caching service actively downloads or refreshes content in the cache when the data is about to expire during times when the firewall is experiencing low activity. The decision to refresh the data in the cache can be based on how often the specific object was requested by users during the previous period. A firewall that does not actively refresh the contents is said to use passive scanning. Prefetch cache contents. Instead of waiting for users to initiate the request to get web pages from the internet, the caching service may prefetch content from frequently accessed websites and store those in the cache. Prefetching can be arranged and happen every morning before the users arrive at work. The firewall administrator must specify which websites should be prefetched. The content should be data that changes infrequently, so it will still be valid when served from cache during the day. Hierarchical caching. Several caching servers can form a hierarchy where the central firewall has a super cache that responds to queries from other firewalls. A common example is branch offices that each have a caching server where the local cache of the branch office is unable to fulfill the web request. It is forwarded to the central firewall, which has access to the internet. Returned results are stored at the central office for the benefit of other branch offices, but are also stored at the cache of the local branch office. Distributing caching. This is perhaps the most important technique for improving cache performance. Instead of using a single cache of a certain size on one firewall, several firewalls work together to benefit from each other's cache. Unlike hierarchical caching, all participating firewalls play the same role but may not necessarily have the same cache size. Two well-known distributed caching mechanisms, Internet Cache Protocol ICP and Cache Array Routing Protocol CARP, are described in the following sections. Internet Cache Protocol ICP. The ICP caching mechanism assumes that each cache server is a group of cache servers works independently. When a request from a web page arrives at a particular cache server, it tries to fulfill the request from its own cache. If that fails, the cache server asks the other servers in the group whether they have the requested object to cache. If the cache servers have the object in cache, the data is sent to the original cache server, which stores the results in its own cache and subsequently answers the user's request. If all cache servers in the group indicate that they do not have the object, the original cache server forwards the request to a higher cache server parent or obtains it directly from the internet. In either situation, the results are cached at the original cache server. The essential difference between an ICP request to a sibling cache server and a parent cache server is that the sibling may just answer miss if the object is not in its cache, whereas the parent goes out and gets the object itself if it is not present in the parent cache. The CARP, or Caching Array Routing Protocol, CARP. The CARP caching mechanism works differently than ICP. Instead of sending queries to all sibling cache servers in the group to determine who has requested the object in cache and then duplicating the returned object from the sibling cache server in the cache of the original cache server, CARP knows which sibling might contain the requested object or will contain the object after caching has occurred. A cache server that uses CARP performs a mathematical calculation on the requested URL to determine which cache server in the group should handle the cache request. That particular cache server is contacted and then gets the caches the object if it was not present in the cache already. The result is returned to the original cache server where it is not being cached but immediately forwarded to the requesting client computer. In this way, each object will only be in the total cache once, and the mathematical calculation can predict which cache server will contain the object for each URL used. Web browsers at the client computer may even know the mathematical calculation itself and send the web request to the correct cache server in the group directly. The same caching mechanism used to cache content from web pages on the internet can be used for web pages from web servers behind a firewall being requested by users on the internet. This is called reverse caching. Dividing the load. Using a cache to store previously requested web pages is one method that improves the performance of a firewall. Another method that fulfills the requests of users more quickly is to use more than one firewall in a group and let them work together by sharing the load of users' requests among the grouping firewall computers and letting them work together has two benefits. Improved performance. The total number of users' requests is divided over the firewalls in the group. Each firewall is capable of processing its share of work more quickly than if only one firewall is handling all user requests. Fault tolerance. The redundancy of using more than one firewall to provide identical firewall functionality makes the system less dependent on one particular firewall computer. If one of the firewall computers is unavailable for some reason, the other firewall computers in the group takes over. In the previous sections, we discussed ICP and CARP to share the cache load and cache servers in a group. The other methods used to share the total load of the firewall are DNS round robin. The DNS server is capable of registering several IP addresses for the same DNS name. For example, 10.4.1.1 through 10.4.1.5. If a client computer asks the DNS server to resolve that DNS name to an IP address, the DNS server cycles through the list of IP addresses registered for the same name and responds with a different address every time. Client computers that ask to resolve the computer name each connect to a different IP address. Each IP address should belong to a firewall server. The total number of connections to the DNS name are divided equally over IP addresses listed in DNS. However, this scheme doesn't take into account how busy the firewall using the IP address actually is. In fact, when one of the firewalls is unavailable, the DNS server will happily refer a portion of the requested connections to the unavailable firewall. Software load balancing, either implemented on firewall servers itself or on a router just before the group of firewalls. The load balancing software divides requested connections among the available firewalls. The software may even sense how busy a firewall is at a particular moment and divide the load based on this information. If one or more firewalls are grouped together, they need to automatically divide the connections between them, and they need to be configured identically. This configuration should be done manually or by some sort of automatic synchronization mechanism. Most firewalls allow for automatic configuration. If firewalls are grouped, this automatic configuration should be repeated for each firewall. So I'm going to leave it here this evening for this video. If you like listening, please consider like, sharing and subscribing. Thank you.